Alright, in this video here we're going to talk about angle of elevation and angle of depression. Right, so the key thing to remember for these angles, these angles come up when we're doing word problems and we're viewing something, either we're looking up, that's an angle of elevation, or we're looking down, that's an angle of depression. Right? The key thing is that the angle of elevation or depression is always measured in relation to the horizontal, right? The horizontal line going straight, like from your eyes, straight out to the horizontal. That's your frame of reference. If you're looking above that horizontal line, you have an angle of elevation. If you're looking below the horizontal line, you have an angle of depression, right? But it's always in terms of the horizontal. I cannot stress that enough. I've seen a lot of students in the past make mistakes trying to define the angle, especially the angle of depression is the one that usually people make a mistake on, defining the angle of depression in terms of the vertical line instead of the horizontal line. Right? They're both in terms of the horizontal. If you remember that, then doing these problems is not too hard to figure out. All right, so the angle of elevation, we have our horizontal, straight from our eye level, straight across. The line of sight, so the line directly from our eyes to whatever it is that we're looking at. Like I said, if that line of sight is above the horizontal, the angle between the horizontal and the line of sight we call the angle of elevation, right? Elevation means looking up or going upwards, so it's the angle of the elevation of our eyes, right? Angle of depression is when we're looking below the horizontal, right? So the horizontal, again, is from our eyes straight out to the horizon, right? If our line of sight, if what we're looking at is below the horizontal, the angle between the horizontal and the line of sight is what we call the angle of depression, right? Depression means going downward. All right, so again, these are both defined in relation to the horizontal line, never the vertical line. Don't make that mistake like so many other people in the past have done. One other thing I do want to point out here, so let me actually erase one of these here, just so I have enough room to draw it. Actually, I'll erase both of them. So if we have our angle defined not in terms of the horizontal. So let's say we're standing on a hill, and we're looking up that hill at something that's on the top of the hill. So there's something up here that we're looking at, and we define the angle in terms of not the horizontal, but in terms of the hill itself. Right, so this angle between the hill and where we're looking, and it's a horrible picture. So just think about it in terms of, all right, I have the slope of the hill, and then I'm looking up from the hill. Right, we call that the angle of inclination. Right, we don't call it the angle of elevation because that angle is not defined in terms of the horizontal. Right, it's defined in terms of the slope of the hill. And then if I look up from the slope of that hill, the angle between those two slopes is the angle of inclination, not the angle of elevation. Right? So it's just a terminology thing that you have to be aware of. Some word problems, if you have something like this where you don't define it in terms of the horizontal, they use a different word. They use angle of inclination, but it's just the angle between whatever the physical object is, the hill or whatever, and then the direction that you're looking. All right, so that's the terminology we need to use to do these problems. I'm going to pause the recording here and put up an example, and we'll work through that example problem, working with some angle of inclination or elevation or depression. I forget which one this first example is going to be, but you'll find out real soon. All right, here's our example. We have a redwood tree which casts a shadow 532 feet long. We're asked to find the height, which I misspelled, find the height of the tree if the angle of elevation of the sun is 25.7 degrees. All right, so to do one of these problems, it helps a lot if you draw a picture of the situation, just so you have an idea of what's going on. So drawing a picture also helps when it comes to forming a triangle and labeling the sides correctly and choosing the correct trig function to use to solve the problem. Having the picture there, having the diagram really, really helps. Right, so I've got a redwood tree, so there's my picture of a tree, cast a shadow 532 feet long. So here's the shadow, which is 532 feet. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So the sun is going to be up here, right, nice blue sun in the sky today, shining down, and it's going to hit the top of the tree and then come straight down and hit the end of my shadow, and pretend I drew a straight line there. I didn't quite pull that off, but you get the idea, right? So the straight line should go up to the top of the tree and then to the sun. right? The sun would have to be up here in these words in order for that to happen, but that's how this is working here. All right, so what I have then is really I have a right triangle, right? We're assuming, well, even if the tree itself is not growing up straight, you can draw a straight line from the height of the tree, the top part of the tree, straight down to the ground, and then, you know, the shadow is 532 feet from there. So 532 feet is this side, and we know that the angle of elevation of the sun is 25.7 degrees. So this angle down here is 25.7 degrees. Right, angle of elevation, again, from the horizontal up, if I look from the horizontal straight up towards the sun, it's an angle of 25.7 degrees. All right, and what I'm asked to find is the height of the tree. So I want to find this side of the triangle over here that I labeled H for height. All right, so there's the situation. And if you didn't watch the video that I did on solving triangles, you might want to check that out. We're not going to solve this triangle. Solving a triangle means finding the lengths of all the sides and the measures of all the angles. We don't have to do that here. We just need to find the length of one of these sides, the one that corresponds to the height of the tree, that vertical side of the triangle. But the methods we use are similar to what I talked about in that other video of solving a triangle. All right, so what I need to do in order to pull this off is look at the angle I have, right, which is this 25.7 degree angle, label the sides relevant to that angle. So like the opposite, the adjacent, the hypotenuse, what sides do I have and what sides am I trying to figure out? Well, the H over here, that's the side that's opposite from my angle, right? From here going across, that's the opposite side, right? The line of sight towards the sun would be the hypotenuse of the triangle, and the shadow, the 532 feet, is going to be the adjacent side, right? That's the side that's connected to the angle, but not the hypotenuse. All right, so I want to label my sides, and when you're doing these problems, you don't have to write them down, but you have to be clear in your head which one is which, and it might help to actually write them down like I did here. All right, so we have the opposite side, we have the adjacent side, the hypotenuse we don't know anything about, and frankly, we don't care in this problem anything about the hypotenuse. Right, so I've got my angle, I want to find the hypotenuse, and I know the adjacent side. So now I have to think of, well, which of the three trig functions, sine, cosine, or tangent, which one of those three relates the opposite side to the adjacent side? And if you don't know just by thinking of it, think back to SOHCAHTOA. Right? If you haven't seen the videos that I've done on the definitions of the trig functions in terms of right triangles and SOHCAHTOA and all that, you definitely should check those out and understand, you know, what this means in terms of a right triangle. Right? But if I want the opposite side and I know the adjacent side, I need the trig function that relates the opposite and the adjacent, the O and the A, which is the TOA here, and the T stands for tangent, which tells me I'm going to use the tangent function here. Right? So choosing which of the three functions, sine, cosine, or tangent, it's all about which side do I know and which side am I trying to find. I know the adjacent, I'm trying to find the opposite, I need the OA, so I need to use the tangent function. All right? So tangent of my angle, 25.7 degrees, is equal to the opposite side, which is H, over the adjacent side, which is 532. Right, so I use that definition of the trig function in terms of the right triangle, and I put the opposite side over the adjacent side, and now I need to solve this equation for H. Right, so the major task in doing a problem like this, one is getting taking the word problem and getting an actual picture down on paper or in your head of what's going on and where the angle is and what side you know, and then figuring out which of the trig functions you need to use based on what side you know and what side you're trying to find. And after that, it's not too hard to figure out, right? So if it's H divided by 532, I need to multiply that 532 to the other side. So it's 532 times the tangent of 25.7 degrees, and that's going to equal H. Right now, if you watch the video that I did on solving a triangle, the angle we had there was 30 degrees, which was one of the angles we know from the unit circle. 25.7 degrees is not one of the angles we know from the unit circle. And so, for a lot of these, trigonometric word problems where the angles are not one of the nice ones from the unit circle, like 30, 45, 60, 90, 120, 135, 150, so on. If it's 25.7 degrees, it's calculator time. All right. Since our angle is measured in degrees, make sure your calculator is in degree mode. Right, so mine there, if you look at the third line down, it has radians and degrees. Mine is in degree mode right now, so I'm all set. But for a lot of these trig problems, some are in radians, some are in degrees, so you have to make sure your calculator is set the right way. Once you're in degree mode, though, just type this in. 532 times tangent of 25.7. All right, that's all I have to do. Once I get this equation figured out and I have the h by itself, I just type that in the calculator, hit enter, and I get my height of my tree, which looks like 256. It's backwards on there. 256.03. So my height is about 256 feet. We were talking about feet, right? Yeah. The shadow is measured in feet, so my height is also going to be measured in feet. All right, so this redwood tree is about 256 feet tall. All right, so that's how tall the tree is. So once again, it's all about reading the problem, being able to draw a picture, label it appropriately. Where's my angle? Where is my shadow? My 532 feet. Obviously, the shadow is going to be on the ground. If you can't figure that out, go outside on a sunny day and look around a little bit. Right? Knowing the angle of elevation means the angle from the horizontal up looking towards the sun, so you know where to put that 25.7 degrees. Remember, angles of elevation or depression are always in relation to the horizontal. So don't put the angle up here as 25.7 degrees, right? The angle in relation to the vertical side, it's always in relation to the horizontal side. That's usually the mistake people tend to make on a problem like this, is just putting that 25.7 up here instead of down here, right? So it's always in terms of the horizontal when you're doing angle of elevation or depression. So just make sure you have that. And then once you have it set up, it's just choosing the correct trig function. Which side do I know? Which side am I trying to find? So katoa, which one of those has those two sides in it? That's how I choose my sine, cosine, or tangent. And then you set up the equation and you solve it from there. And most of the time you use your calculator to get your answer. All right, so that's one example of angle of elevation, angle of depression. I am going to do another video where I do one or two more examples, depending on how long it takes and how much time I have, where we look at some more of this type of stuff. So if you want to see more of it, make sure you check out that next video I'm about to do.